Have you ever wondered what happens when you post something online? How does a giant social media site keep track of literally billions of posts, comments, and shares? It all comes down to a tiny but super powerful piece of data, the unique ID. And today, we're going to dive deep into the surprisingly tricky world of making these things at a crazy scale.
Okay, put yourself in the shoes of an engineer at a huge social network. Your job? You need to come up with at least this many unique labels, or IDs, every single day. Yeah, that's a billion. A billion brand new, totally unique identifiers for every single thing that happens on your platform. And here's the kicker. You can't have a single duplicate, not one. Because one little collision could mean a lost comment, a payment going to the wrong place, or just corrupted data everywhere. So how do you do it? Well, that's the huge engineering puzzle we're going to solve together, step by step. All right, so let's get into it. Before we start building anything, we need to define what our perfect ID generator actually has to do. What are the rules of the game here? Okay, here are our 4 non-negotiables. First, uniqueness. Every single ID has to be one of a kind. No exceptions. Second, scalability. It's got to handle that billion-a-day fire hose of requests. Third, availability. The system can never, ever go down. It has to be ready to spit out an ID 24/7. And finally, it's got to be a 64-bit number. Why? Because that makes it super fast and efficient for databases to handle. So, to keep track of how we're doing, we're going to use this scorecard. As we try out different ideas, we'll see which boxes we can tick off. Think of it as our roadmap to the perfect solution. All right, attempt number 1. Let's start with something you might have heard of, the UUID, or Universally Unique Identifier. It's a really common tool, and for good reason. But let's see how it actually stacks up against our requirements. The logic here is pretty slick, actually. Every server in the system just makes up its own random ID. No need to check in with a central boss or anything. It sounds amazing for speed and scale, right? But yeah, there's a catch. So what's the problem? Well, while UUIDs are super easy to get going and they scale like crazy, they failed 2 of our big tests. First, they're 128-bit, which is double the 64-bit size we wanted. That makes them kind of clunky and inefficient. But the real deal breaker? They aren't guaranteed to be unique. The chance of a collision is tiny for sure, but when you're making a billion of these things a day, highly unlikely just doesn't cut it. Okay, let's update that scorecard. We get a big checkmark for scalability and another for availability. That's a good start, but we get a big red X on uniqueness and on the 64-bit rule. So we got to do better. So for our next attempt, let's swing the pendulum in the complete opposite direction. Instead of every server doing its own thing, what if we had one central source of truth, like a single database that just hands out numbers, one by one by one? Now, this approach, it absolutely guarantees every ID is unique. All the other servers just line up and ask the database for the next number in the sequence. Duplicates? Impossible. But you can probably see where this is going. It creates a whole new world of problems. So it perfectly solves our uniqueness problem, and we can make the IDs 64-bit, no problem. But we've just created a massive bottleneck. That one database is now a single point of failure. If it hiccups, the whole system grinds to a halt. And trying to handle a billion requests a day? Forget it. No way. Back to the scorecard. You can see we've basically just traded problems. We got our check marks for uniqueness and the 64-bit format, but we lost scalability and availability. We're still stuck. Okay, what if we try to get the best of both worlds? Let's keep our central service, but instead of it giving out IDs one at a time, what if it handed out big chunks of them? Like, hey, server 1, here's a million IDs for you. Server 2, you get the next million. This is a huge step in the right direction. Now, each server has its own block of IDs to work with, so the system is scalable and highly available. But it's also super wasteful. Think about it. If a server grabs a range of a million IDs and then crashes, all those unused numbers are just gone forever. We are so close. Look at the scorecard. We've ticked 3 out of 4 boxes. We have a system that actually works. It's just not very elegant, is it? We need a solution that gives us all the good stuff without being so wasteful. And that brings us to the breakthrough, a real-world solution that was actually developed by Twitter, and it's called Snowflake. And let me tell you, it's a beautifully simple, incredibly powerful idea that solves all of our problems at once. Okay, this is where the genius of Snowflake really shines.
It manages to pack everything we need into that tiny 64-bit space. This isn't just some random number, it's a really cleverly constructed piece of information. So how does it work? Well, it's broken into parts. The first big chunk is a timestamp, right down to the millisecond. The next part is a worker ID, basically a unique number we give to each machine, so we know server A is not server B. And the last little part is a sequence counter. It just counts up really fast for every ID made in the same millisecond on the same machine. So by combining time, machine, and a sequence number, Snowflake guarantees uniqueness, and it does it with no central bottleneck at all. And get this, those 41 bits they use for the timestamp, that gives the system an incredible lifespan. It can keep generating unique IDs that are sortable by time for about 69 years. Talk about future-proofing, right? So let's take one last look at our scorecard. With Twitter Snowflake, we get a clean sweep. Check, 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 and check. It's unique, it's scalable, it's always available, and it's a perfect 64-bit number. This is the elegant solution we've been looking for all along. So why do we even care about all this? Why does it matter? Because getting these IDs right is what stops things from going horribly wrong. It prevents stuff like duplicate payments, lost purchase orders, or just totally corrupted data. It's like the invisible foundation holding up a reliable system. You know, this whole journey from a simple UUID all the way to this elegant Snowflake design really shows that system design is always about trade-offs. Snowflake was a perfect solution for the challenges of its day, back in 2010, which kind of leaves us with one final big question. What new challenges, maybe scale or speed or even security, will the next generation of unique IDs have to solve?